Okay. So we spoke about database, we spoke about OLTP and OLAP. OLTP is the database which actually is a transactional database. That means every transaction is getting captured, you know. Then we briefly spoke about OLAP. OLAP is a database which is used for data analysis purpose, right? So you perform warehousing and machine learning kind of work that we'll do. Actually, uses OLAP application. This OLAP application is it will be time bound, right? Generally, it's a subset of OLTP generally, okay? And you say time bound in the sense, okay, here you'll say, okay, give me the data for last 1 month, last 1 year, last 3 months. Okay, so your DBA would then give you the subset of the transaction database for you to perform your analysis. Okay, so there's a different concept. Once we get into analysis, we'll briefly touch upon that. But for now, let's ignore OLAP. Okay, because our focus is on OLTP. Our focus is to learn the transactional database. Okay, so transactional database. Okay, we we spoke about some basic rules, right? So we say, okay, CORDS rule. I put a slide for CORDS rule, right? Yeah. So if you want to see what is CORDS rule, let's go and refer here. So I'm going to show you how to what happened. Okay, I'm going to share my screen. So in simply, if you type CORDS rule for RDBMS, okay, in internet, you get this. What it says is, this rule states that for a system to qualify as RDBMS, it must be able to manage database entirely through relational capabilities. Okay, what is relational capabilities? We discussed yesterday, right?
Yes, sir. It's when
Interlinked.
it's arranged a table.
Okay, so if you remember yesterday, let me switch to right. This is what we said is relationship, right? Your
Yes.
employees and department. Okay, we are able to. So it says that if you are able to manage the entire database, everything that is required for a database, okay, to work, if you can manage entirely, then you can say that it is okay. It is a relational database. That's called COTS rule 0. Okay. Now let's look at other rules and what it means. Information rule. All information, including metadata, data about the data, is to be represented as stored data in cell of table. The rows and columns have to be strictly unordered. Okay. So one thing, I told you yesterday that if I need to save email and phone number, I should not put them in the same cell. What is cell? Where your row and column meets. Okay. So row and column meet. So, that's where, you store one single information. You cannot have multiple information because I need to get email ID. Okay. I don't want phone number. I want only email ID. You should give me only email ID. That's point one. Second important point it says is they have to be unordered. Okay, that means to reach to email ID column, I don't have to go through other columns. You should be able to directly go to columns, and there should not be any order. You should be able to access data in any order. Okay, that's called rule number one. Rule number two is guaranteed access. Okay, it means so rule number one is about information. Rule number two says you should be able to access every information. It's not like that you have added some data and now you don't know where it is. You cannot access. It's there in the database, but I cannot access it. Okay, each and every single, data you should be able to access it. I need to know email ID of Sachin Tendulkar. I need just one particular information, and the data should be able to give me that. Okay, it one thing is, of course, you can you can list all the information, but listing all the information is not having access. Access means I want to know, okay, on which date so and so employee joined the company. So and so employee. Okay, I'm talking about one specific employee, and I'm talking about joining date. So the employee joined on so and so date. So I will need to know exact date. I need to know when it, I need to know one specific information about one particular thing. So each cell has to be accessed. Okay, so we access using table name, primary key, and the attribute name. Okay, so your column is also called as attribute. Your tuple is also called as row. Okay, now table, you know what table means. What is primary key? Primary key is a constraint. Okay, that means every row of it is at column basis. Okay, primary key is row, but it is applied on column. That's how the entire row of that column will be called primary key. So when you put primary key, does two main things. First thing is that it makes sure that the column does not get duplicate values. Okay, so it cannot get. Okay, let me again open Paint and show you. Okay, so here, let's say this is your row, right? And I have here employee ID as the column, which I have put as primary key, EMP-ID. So EMP-ID is the column which I have put the primary key. Now here you cannot have duplicate values, and you cannot make it, and you can't have it null. So it cannot be null, it cannot be duplicate value. It has to be unique value itself. Okay, that's what primary key says. That's one point, making sure that column does not have duplicate value or null values. Second important thing, and it is very important, is that it creates what is called as index. Now index is the second database element, we call them, that we're talking about. First is table. This is table, right? So so yesterday we introduced the concept of table. Table is where all your data is stored. Index. What is index? So index is also like a table, okay, and it will have only two columns. Okay, first column is your primary key, EMP-ID, EMP-ID, and second column, okay, so let's say 101, will have the location in the memory where the data is stored. See, your data, when you have, it will be stored somewhere in the memory. That memory will have a location. That location is given in your hexadecimal format. So this date, see, for us, it is visible as a logical structure, but actually it is stored in hard disk somewhere. That location is added here. So index has the primary key number and the index number. What happens when you are performing search? Okay, I want to find the email ID of Sachin Tendulkar. And if I know the employee ID of Sachin Tendulkar, I can say, give me email ID where the employee ID, or give me the email ID of an employee whose employee ID is 101. So it doesn't go to the table. If that employee ID is saying where, I'm saying whose employee ID is 101. So I'm searching based on employee ID. So remember, I'm searching based on employee ID. Okay. Now if employee ID is 101, okay, so employee ID. Let me go and check if there's index or not. If there is no index, manually it will go and check one by one. Is it 101? No, it is 101. No, it 101. No, 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 no. It might find somewhere here. So if you do not have index, it is very slow. I mean, it can be fast also. If you're checking about first column, first row rather, you'll get it fast. But if you're talking somewhere down, the data can be 50,000, even more, much more than that. So you won't be able to reach. Okay, it'll take a lot of time. Okay, but if you have an index is very much like your index in the book, right? When you turn your pages at the back, they'll have topics and the page numbers. So if you want to go for specific topic, you don't go through page by page and searching for the topic. You'll go to the last page, index page, and look for the topic. Topic will be listed in alphabetical order, right? Topic will be listed in alphabetical order, and you go through the topic, you look at the page number, and then directly go to that particular page. Isn't it faster than going through each page to look for your topic? See, when you want to learn everything, it makes sense to go from chapter 1, chapter 2. But now once you have read once, and you don't need to go through entire book, because probably 70% of the stuff, or 80%, you don't know 20%. So you'll specifically look for specific topic. That specific topic, okay, is given on a particular page. So index will help you to directly land on those topics. Same thing here, the same concept of index in database also. So here, instead of going page by page, instead of going row by row to search for your topic, you come here, and this employee ID will be listed in increasing order. So there is a concept of binary search, okay, using which, again, we'll talk about it later, but let's understand that if it is listed in alphabetical order, you can easily go and see, okay, I need to check for employee ID 110. 110 is here. So you will land up at 110, look for the memory location, and directly come here, and you have access to all the data here. Okay, so index, if you create a primary key, index is automatically created on that particular column. Your table can have more than one index, but table cannot have more than one primary key. That means you can create index on any column. Generally, wherever the search is done, right? Based on, let's say here we are doing based on employee ID. So it makes sense to create index on employee ID. If you're doing, let's lot of search on phone number. Let's say your database design is such that you are doing lot of search on phone number. Then it makes sense to create an index on phone number. Okay, but phone number will not be your the primary key. Primary key will always be only one in a table. Okay, so of course, if your phone number is not a primary key, then you have to manually create an index in that case. Okay, we'll see all these things towards the end. Once we are done with the basic, we'll see index views and all those things, how to create and manage all those things later. But first, now let's focus on table and the data. So we said that when you create table, you have to have a primary key. Okay, I mean, as from database, it's not restricting. It's not saying that you have to have a primary key in a table. Okay, database will not restrict. You can create your, you can choose to have primary key or not to have primary key. Okay, not mandatory from the database side, but logically you should have a primary key. Okay, the date, because then you will not be able to access each data, right? You will not be able to access each specific row. So going back to the codes role, did you understand what I'm trying to say here? Each of the data has to be, okay, accessible. So you use table name, you use primary key. So give me Sachin's email ID, okay, from table employees, where Sachin's employee ID is 101. So you'll have a column called, so using 101, you'll be able to get that row, and then you have a column called as email ID. You will pick the data from email ID. So using these three things, you will be able to access any data from a table. Table name, primary key, and attribute, okay, column name. So using these three, you will be able to access any data. Clear?
Yes, yes.
Yes.
Okay. So yeah, so this is called as Court's second rule. Okay, Court sets up the, he came up with these rules, and then other companies, when they created database, they followed these rules, and these rules were given in 1970s by Court, who was an employee of IBM then. Okay, so IBM came up with the first RDBMS, but then later companies also came up there. So this is called guaranteed access, where you will have access to all the data using three things only: table name, primary key, and the column name. Then rule number 3 says, okay, these first three rules are important, okay, and then the other rules, okay, will probably, just go, may not be in that detail, okay. So, systematic treatment of null, okay. Null means missing data, does not means zero, does not means -1, does not mean anything else, okay. So you should be able to treat null differently, separately. And we will see when we perform reading the data from database, you will actually see what I mean. Okay, it means that you should treat null as a null value, not as a zero or some default value. Null means it is not there. Okay, it's not there means it's not there. You cannot assume that it is something else. Okay, that's what it says, that null should be treated differently or systematically. Active online catalog. Okay, it's like um, um, data about the data, right? So you have a database, right? You have all the data. Your catalog will tell you, okay, what kind of table it is, what kind of data it has, okay, so that I'll be able to know about the table without getting into the table. That's called cataloging. Okay, then there should be a language which will be able to efficiently access the database. So of course SQL. Okay, so SQL is the language that we will use to connect to any database or any RDBMS. We're talking about RDBMS database itself. So using SQL, you can connect to any database. So rule of 5 talks about a programming language which we know as SQL, right? Then view updation rule, relational level operational. Okay, so you should be able to update, delete, add, all those things talks about. Okay, data can be updated. So if I make any changes, okay, any user, you should be able to see the changes which I made. Okay, it should not be, stored or delayed, that kind of thing. So that's what it says. Okay, you should be able to perform other operations as well. Physical data independence and logical data independence. Physical data is different, logical data is, I told you yesterday. Physical data means files. Which files, how many files, where all files are there, what kind of information each of the files have. We don't have to worry about. Our focus is only on the logical aspects. So logical aspect as like tables, indexes, views. These are the things that we generally deal with. Integrity independence. Okay, data should be able to enforce its own integrity rather than using other programs. Okay, so you do not write other programs to tell that which data has to be unique. Okay, the primary key actually. So when you make something as a primary key, you are actually creating that data as a data integrity, right? Then you have distribution independence. Okay, generally database, okay, will be stored somewhere. Okay, now talk about Amazon database, it's stored somewhere in the Amazon server, somewhere maybe in US, right? But we all are able to access from different parts of the world. So it doesn't matter where the database is, you should be accessible to everyone when, if they are, if they, if they are the right user. Okay, that's what it. You cannot have database on everybody's machine. Okay, you'll have a single database which everybody will connect to. Okay, so if low-level access is allowed to a system, it should not be able to subvert or bypass integrity rules to change the data. Okay, it can be achieved by some sort of looking or encryption. Okay, so username, for example, right? Username, password. So username and password combination should not be same. So what it's saying is that when you access the data, you still have to go through this integrity rule. Okay. So these are 12 rules, but I just said first 2-3 rules are important, which is good to know that, information, each cell should have unique information, guaranteed access using table plus primary key plus the column name, and you should be able to treat null like a null. Okay, that's what it means. All good so far? Any questions here? Say something, yes, no.
No, sir.
If you say yes only, I'll be able to know that no, right? Okay. So that's all about theory aspect of database. Okay. So we're talking about RDBMS, we're talking about database where data is stored in relational format. Okay, you should be able to access each row of the data. Okay, and using table name, column name, and the primary key, you should be able to access each and every data. Let's see how to implement it. But before we start implement it again, talking about relationship, right? Relationship is when the relationship is between two tables, right? How these two tables are related. Okay. So we say that employees and departments are related. Now, if we talk about relationship itself, okay, it can be of three types. Okay. Relationships in database. So we say one-to-one relationship. Okay. One-to-one relationship means one value, okay, will have only one another value, corresponding value. For example, your employee ID and name is one-to-one. Your name and your phone number, assuming that I only need to know one phone number, right? I want your phone number, let's say, to put in the records. So you'll give me only one phone number. So your number and your name are connected one-to-one. Okay, your email ID and your name, or email ID, your employee ID. This is called as one-to-one relationship. When two attributes, okay, has one-to-one relationship, means one attribute will belong to only one other attribute, right? So one attribute belong to only one other attribute. Okay, so we say one-to-one, right? Now this can be belongs. Okay, example, let's say email ID and phone number. Okay. Second one is a one-to-many or many-to-one. Depends upon, how you look at it. Okay. So it is one-to-many or many-to-one. Okay. Department and employees. Okay. So employee ID and department name, let's say. One attribute, okay, can have multiple other attributes. Okay. So you have employee to department. Now, one employee will belong to only one department, that is one. But one department will have multiple employees. Yes or no? So
Yes,
if
yes.
one department has only one employee and one employee belongs to only one department, we say one-to-one. But one employee will belong to only one department. This is the one part. And one department will have multiple employees. That is called many part. So this is example of one-to-many. Then you can have, or what, see, many-to-one or one-to-many, doesn't matter. It depends upon which side you're looking for. If I start with department first, then it becomes many-to-one. If I start with employee first, it is one-to-many, right? Next is many-to-many. Okay. From both the side, they can have multiple values. Okay. So here, okay, let's say you're talking about Okay. So let's say you're talking about courses and students, right? Students and say subjects. Okay. One student will study multiple subjects. One subject will have multiple students. So both sides many to many. Okay. Students will study multiple subjects and some subjects will have multiple students, isn't it? So it is many to many. So this is how you can have three types of relationship. But what is the importance of relationship? Okay, how do you practically implement it? Okay, so when you have one to one, then what you do is you put them in one single table. Put all these attributes in same table. So you will totally get one table. One to many, you create two tables. And join them using foreign key. This is what we did in department and employee, right? We
Yes.
connected the employee to the department. So we created two tables, one for employee, one for department. Okay. Now, when you have many to many, it says create three tables. Create three tables. One for one each for two attributes. And third table for the relationship. Okay. So subject and student. It says you create one table for students and their one-to-one relationship, like student ID, name, phone number, email ID, etc. Second table you create for subjects. Okay, subject ID, subject department, faculty, whatever. Third table, okay, is created as a dummy table to link these two tables. Okay, and we'll see an example later. Okay, I'm going to show you what I mean. So now here, okay, and this is very interesting interview question. Okay, when you talk about entity is your each of the table, like employee, okay, subjects, okay, department, student. These are your entity. Relationship is the relationship between them. Okay, so can relationship be converted into table? Answer is yes, only in the case of many to many. Only in case of many to many, relationship can be converted into a table. Okay, not in case of one to one or one to many. Many to many only, you'll create a third table to maintain the relationship. Okay, they'll ask you how to handle many to many relationship. Okay, answer is create a table. Okay, now why is that so? Why do we need to create, okay, many table? So let's see an example here. Let's say, okay, student studies data structure, okay, machine learning and Python. Okay, and you have subjects where DS has 45 students, ML has 25, and Python has 40 students. Now, if I try to add students in student table or in subject table, okay, just like the way we handle one to many, what will happen? Let's say this is a student table. So you have roll number, okay, you have student name, let's say. Now, if I start putting subjects here, okay, something like DS, comma, ML, comma, PY, then I'm violating that which rule? Information rule. Rule number 1. Each
Yes,
cell
each
should
cell
be
has
able
should
to
be
give
one.
me, yes, one unique information.
Yes.
And here I want to know, okay, one subject. I won't be able to access one subject. So one option is you create subject 1, subject 2, subject 3. Subject 1, okay, let me, okay, maybe we'll insert new row. Okay, I'll go here and I'll say split, right? How do I insert a new row? Insert table. See this. Maybe we'll say split. Okay, so split, number of columns is fine. Number of rows will make it 3. Oh, no, that's not the way I wanted to split. Okay, so let me say yes, this is what I meant. Okay, so I can say subject 1, subject 2, subject 3. Okay, DS, ML, PY. Now, what is the problem here? Okay, I can create this one. I can create another table. I can create another table with, let's say, subjects detail. Okay, so subject ID, subject name, and whatever, HOD or faculty. Okay, I can say subject ID 1 DS. Okay, and put here 1 here. I can do that. Okay, I can manage with 2 tables, right? I don't have to create third table. The challenge here is if I need to know data science, how many students are there? Now, here you might have data science. Okay, in some other student might be subject to data science. Some student might be subject 3 data science. Some student will have 40th as data science. So I'm not able to get the data from one attribute. I have to look through 40 attributes, 50 attributes, 50 attributes, and let's say if I have 1000 students. So I need to check 50 attributes or 1000 students to get one subject. Again, if I need to know for ML, again I have to do 50 attributes. Okay, that's one problem. Second problem is how many columns should I create? 50, 55, 60. There could be other student which might have only 8 subjects. There could be one student, undergrads might have 50 subjects, right? So how many columns do I create? It doesn't make sense that way. Okay, so you do not perform like this. Okay, so we remove the subject information from here.
Merge.
Okay, we remove the student name from here. Here anyway we don't have a student name. And now we'll create a third table. Okay, let's have some, maybe not so many. Okay, so this third table, what I'll do, I will put some TID, transaction ID, something. I'll put student ID. Okay, I will put subject ID. Okay, sub ID, and here I'll put roll number, right? This is roll number for student. Now I will say this will be 1, 2, 3 like that. 1, 2, 3, go on, right? Here I will say roll number 1, roll number 2, roll number 1, let's say. Subject ID 1, 1, subject ID 2. Now this tells me, okay, I'll create this just a table to maintain the relationship. So now by looking through just 3 columns, I'll be able to know which student have which all subject, and for each subject, who are the students and what is their count. Isn't it? I need to know, okay, how many times one is appearing. If one is appearing 2 times, that means there are 2 students who have taken subject ID 1, which is DS. From here, I will know the DS. Right? I need to know student number roll number 2 is Rohit. What is the subject of Rohit? So I'll check for roll number 2 here, and I'll see, okay, roll number 2 has subject ID 1. So Rohit has only DS subject if we have only 3 rows of record here. So with 3 table, I'll be able to get all the information. This is why for many to many, you create 3 table.
Okay.
Okay. Now roll number will be linked. So you have 2 foreign keys here. Okay, you have 2 foreign keys here. One, right, from roll number to student, right, and another from subject ID here to here.
Subject mode.
Okay, and you will be able to find out all the information about the table. So this is how we end up creating tables. Okay, but before you create the table, okay, we need to understand the process. We need to understand how the system is created. So for that purpose, we use ER diagram. Table is a result of ER diagram. And if you get ER diagram correct, even a fresher can create a table in a, looking at the ER diagram. But to understand ER diagram, to do that, you need some experience, because, okay, it's not that easy to create database. Okay, you make a mistake, you can't delete. Now let's say I created a table, I added 500 rows. Now you realize that no, this is wrong, this is not how we should do it. You have to change the structure of the database. You can delete it, but if you delete it, 500 data will be gone, lost. 500 is still okay. What about 5,000, 50,000? Not possible. So you have to be very careful. And to do that, we use what is called as ER diagram. Okay, we'll see what ER diagram is. Now, ER diagram is a pictorial representation of your database, which we do it before we actually start creating tables and relationships. And so again, I'll take you back to the notes here. So here you say entity, okay, relationship diagram, okay, ER diagram. This is what it says, ER diagram. And you type on images. This is a simple ER diagram. So let's click on it. Can you read this?
Yes, sir.
So you have entity here, and in orange, what do you have? Branch here. And entity and branch can have 3 relationships: deposit relationship, withdrawal relationship, and loan relationship. Okay, so this entity has 3 columns here: name, address, and SSN number. Branch has these details: name, address, and affiliation. Okay, this relationship, when they have these values, it means they are many to many relationship. one-to-one and one-to-many, we will not have, okay, values for the relationship, because that their relationship is not converted into table. Okay, so if it is not converted into a table, you cannot put column names. Only when you convert into table, you have column names, right? So if you see relationship, how do you do with relationship? Rhombus. Rhombus sign indicates relationship, and rectangle is for entity. Rectangle is entity. It will be like a table for sure. Then here, okay, deposit. So entity deposits money in the branch. Entity deposits money in the branch. That's another table that we are going to do it next. Okay. Let's look at few more diagrams. Some can be easy, some can be tough, some can be long, big. Okay. So here you see it is entity relationship diagram for departmental relationship. So you have marketing, you have accounting, you have CEO, you have BD, you have vice president, technical supplier, so on. Okay. What is the relationship between them? This is the relationship between them. Okay. Another ER diagram. Let me take something. Okay, this is one ER diagram. Okay. Now here this talks about only one table. How many rectangle do you see? One.
Yeah.
Okay. So one rectangle. Okay. So you have called student. So this is your table, and uh, um, rhombus, right? Rhombus was relationship, and this oval are your columns. Okay, your columns. So columns again, you see, you have roll number, name, birth date, and phone number. These are the 4 columns. Now name should have first name and last name. This is called as composite, not composite. Yeah, I think it's called as complex. Okay, because one name has got 2 other names. So in database, you will create first name and last name, not name as a column. So you have roll number, first name, last name, birth date, and phone number. Something like this means weak. That means it may not have values. Most of things may not have values. Okay, roll number should be have been underlined. Means this is the primary key. Make sense? So now when you see this here diagram, you can simply, it will be easy for you to, oh, I need to create a table. Okay, I'll create table. Create table student. These are the attributes. I need to add these columns to the table. Take this one. Student joins courses. Okay, this is your student ID, name, and email. Joins courses. So these are the attributes of the courses. So these are one to one or one to many or many to many. What do you think? Student and the courses.
This is many to many.
Many to many? Do you study multiple courses in the university? Probably not, right? So, courses means the branch, right? Like biotech is a branch. That's a course. Multiple subjects you will have. You can't enroll in multiple courses at the same time. Correct? You have to finish one course, and then if you want, then you can join second course, but you can't have multiple courses at one go, right?
Yes, sir. Yes, I was thinking about subjects.
Right. So subject, yes, it will be very too many, but course will be just one to many, right? So one student will belong to only one course, but course will have many students. So here it is probably many to many. Sorry, one to many, right? So let's take this and we will create our ER diagram on the slide here. Okay, I'm going to paste it here. Okay, so this is one example of diagram. Now, your assignment for today is to figure out at least 5 diagram. Okay. Okay. Get 5 diagrams. I'll give you some examples. You can look for airline scheduling.
Like
And
we have to make the
pilot.
diagram or like look for it online, sir.
No, so you look for online and then you can reproduce it by yourself. But
Okay.
main thing is just look for it. Okay.
Okay.
So when something is already there, it's better to learn from there, right? Instead of doing from scratch. So you look so that you understand. And if you're asked to do it, you should be able to do it. Okay. So let's say airline pilot scheduling. How do they do scheduling for the pilot? Okay. I'm just giving some names. You can go beyond this list. Okay. Maybe a banking operation. Okay. Retail banking operation. So where you go and you deposit cash, you withdraw cash, everything that is happening inside the bank. You can do ATM operation, withdrawal deposit at the ATM. You can have okay. This can be a project also for you, right? This is the back end, and if you can put whatever code you can do for Python, you can use Python. For Java, you can use Java. That will become a project. Okay. So for now, we'll focus only on the backend, on the database. So, ATM operation, you can have library management system. All this there are, right? Library management, hospital management system. Okay. Hotel management system. Okay. Let's look at hotel management system. We'll go back. Let's say if you want to do diagram for hotel reservation system, let's say, or hotel booking system, or hotel management system. Management will be little more complex than your reservation system. So let's look at hotel reservation system. Okay. So see, which one should I click? Let me click this one. Okay. All these boxes, red boxes are your entity. Green boxes, rhombus are your relationship. Oval boxes, okay, are your attributes. You have orange boxes also. Probably orange boxes are foreign keys. Okay. So you take that, and the next assignment is take any one and convert that into database. So for next 2 days, okay, we are anyway not meeting Saturday, Sunday, right? Monday, Tuesday, we will see how to create database and add tables. Okay, we'll start today itself. Why wait Monday? So you take one, you collect 5 diagram, take 1 diagram and design the entire structure. Okay, for 2 days. Now there you will understand the challenges. Okay, oh, how do I create this column, or what data type should I give to this column? What data type should it be? How do I link these two tables? Okay, those questions you'll come across, and then you ask me and we'll discuss, right? So yeah, going back to the slide again. Okay, get one, and then I will say pick one of those and convert into database objects or database design. Actually, so this is design and convert into actual database. So you will end up creating tables and things like that. Okay. So we will see a simple one, student and course, and maybe Tuck, 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 tuck. I want to do all like many to many also. So student course is one to many. Because see, if I bring subject, subject will be linked to course. Hmm. Now courses will have multiple subjects. Okay, so let's do this. Let's build 3 tables: student, courses, and let's add subjects also here. Okay, we'll say subjects, and subjects will belong to courses. So that's how student will be connected. So student is not directly connected to subject. Student is not directly connected to the subject. Student is connected through courses have. Student joins course, courses will have subjects. So you can create something like this. Here you can say have or has subjects. Okay, so we'll try to build this. All right. Okay. So you have to choose the database that you want to install and use, right? So next is select the database. My suggestion would be go for MySQL, or you go with Postgres. Okay. So depending upon which system you are using, you can go to internet and say MySQL download. Okay. MySQL download, and okay, you can download it from here. Don't go with enterprise edition. Okay, it'll ask you to make payment. There is something called as, don't go with trial. Okay, this is called community edition, MySQL community. Okay, this is totally free. Okay, so go with MySQL community, or maybe I'll say MySQL community download. Okay, so MySQL community download. Yeah, this is the one. Okay, dev.mysql. You can select whichever you want and you can download it. Okay, so if you are Windows, download this one, server, not the binding test suite. Okay, download this and you follow the steps. Okay, okay, and download. I think I have MySQL steps. Maybe I'll share with you, and then there'll be option called which tools you want to download. Okay, download all the tools. Okay, I'll tell you what I mean. Okay, so this is for Postgres. Okay, so download MySQL database or Postgres database. Okay, now I told you, right, when you download them, it will download a server for you, correct? Okay, so server is like an ocean. You have server, and okay, let's say you have the server. Now, whatever objects that we add, table, index, all these things will be added to this server. But how do I know? How do I access this? That's where you need to use admin tools. Okay, that's where you need to use admin tools. So when you download these will have all those things. Okay, so along with server, so you need server, you need admin tool, you need what do you call command line access. Okay, so your admin tool is like UI. Okay, and command line is where you have to type commands for everything. You have to remember the commands and type. Okay, so obviously admin tool is UI is easier, right? You just have to click, right? You don't have to remember the commands. So these are the things that will install. So let me show you. Okay, let me share my entire screen. Okay, I had my SQL, so let me see if it is still there. Okay, so you see this MySQL workbench. Workbench is the tool, admin tool. So MySQL admin tool is called workbench. Okay, the SQL Server tool is called as Management Studio. Okay, so and this is the command line client. Okay, or shell. I can type commands on the shell directly. So this is your MySQL workbench. So if you download MySQL, it takes time, guys. Okay, so go through the process of installing and install it. Okay, you don't do both. Okay, use only one. Okay, so this is MySQL. You see my screen, right? And these are the servers here. Localhost, and this is another IP address. This is also localhost only. So I'll say, and here MySQL 80 is the database. I'll click on it. Okay, it do not forget the password. If you forget the password, you will have to you only have only one option to uninstall and install it. Okay, see, I forgot the password.
We can save, right? But save password.
Save, yeah, just like you remember your Gmail password, this password. Okay, now I think it's learn SQL. SQL. Yeah, see, it's got connected. If you forget password, admin password, there is no we can recover admin password. You'll have to uninstall it. That's the only option. Okay, so save the password. Okay, you don't want to keep installing, uninstalling just because you lost the password. Okay, so this is my MySQL workbench, and here I'm able to connect to all the databases. You see, this was the last query I had run, so it has saved. This is your library data. This is what I have created. Okay, this comes students DB is what I have created. Okay, Shakila, Sys, and World. These are the pre-installed databases, inbuilt databases. These are the user database that we created. Okay, from here we will be able to run all our commands. Okay, so we will see all this. So this is for MySQL. Something similar you have for Postgres also. It's called a admin something, AG admin. Postgres, okay, SQL. So Postgres SQL, okay, it's not coming here. Let me go to the programs directly. Okay, P. Okay, Postgres, I'm using version 15 and PG admin. Okay, PG admin is like workbench for Postgres. If you click on it, okay, these are UI version. You can, it's easy to handle, run the code. You can see the output, all those things here. So this is called PG admin, Postgres admin. Again, here also you have to remember the password. If you don't remember the password, you can't access. Okay, and this is where, so now we will learn some queries, and those queries we will fire from here. Okay, So let's say I have created this database library. I need to create a table in library. So I'll say create table. Okay, let's first see what are the table that you already have in the library. Expand this, click on tables. Books, member, publisher, users. These are the tables which are already created. You want to see the column names of these? You again expand here. Okay, so these are the indexes, foreign key, triggers. Trigger is another database object. We'll talk about it later. See, these are the columns. Okay, you want to see what book ID? It'll open a window. Okay, or maybe table. Okay, now I'll say copy to clipboard. Okay, you see it here, it's showing you. Okay, so you have book ID, author. So it is book ID is integer and primary key. Author is varchar 25. Title is varchar 25. Price is float 7,2. Total 7, including decimal point, is 7, and 2 is the decimal point. Available, yes or no, tiny int 1. Publisher ID int. Publisher ID bold, that means it is a foreign key. Okay. So like that, I can say create table, a new table. Create a table, this is the syntax. Okay, this is how you create a table. Create table, table name. Now, so I have access to multiple database, right? Which database should it go? So two options. One, either you say use library. So that's when and every command should have a semicolon. This is how you end a command in SQL. So use library means that I'm going to use library database. So whatever you are doing, do it in the library. Or you can simply say library dot a new table. Okay, you can use one of these options. Okay, here case insensitive. I told you SQL is case insensitive. Doesn't matter whether you give small letter or capital letter. It doesn't really matter until and unless you give in the quotation. Text data, varchar data in SQL is also case sensitive, but commands are not. Okay, so here if I say create table in lowercase, uppercase, mixed case, library, new table, all these things doesn't matter which case you use. But when you insert a data in varchar, okay, like name all caps and mixed caps, they are different. They are not same. So create table, I'm going to say sample col int, okay, sample name varchar 10. Close it. So you have column name, data type, and constraint, primary key or whatever, comma. I'm adding one more column. So comma, column name, data type, and comma if required. Okay, this is last column, so no need to have comma. And you close the bracket here. Now you can select and run this power button. So say execute the selected portion of the script only. So if I have multiple, so I have two queries, right? One query is this, one query is this. If I select and run this, only selected part will be executed. Here you see entire, okay, everything will be executed. So let me go step by step. I'll say one here. Okay, use library has come. Now I go here and run again. See, tick mark means, green tick means your program, your command has run successfully. Create, this is the command, action, time. Okay, 0 rows affected because it did not create any row. Okay, this is the time duration that it took to execute it. So now if you go and say table, refresh, because you have to refresh it, refresh all. Now you see here a new table is created with columns, sample column and sample name, right? See, this is what we had given, right? Sample col is integer and sample name is varchar. So this is the new table which we have created. Okay, So we have not created primary key and foreign key. We will see in the next on Monday. Okay. So for weekend, just create, figure out um, five ER diagram, install MySQL or whatever. Okay. MySQL is better, or Post, whatever. I know it's up to you. You install that database, installation, 5-year diagram, and create this table. Do not run it. Okay. I'll tell you a few more stuff. Then you run it. You create as much as you can. Okay. Create table, add column names. At least this you can do it. Okay. We'll learn about primary key, foreign key. Then we'll come back and we will create a table and we will run it here. Is that okay?
Yes.
Yes, sir.
Okay.
Yes, sir.
Perfect. Now let's see PG admin has come up or not. Yeah, this has come up. See, so this is server, and here I have my profile. Now see here, I have to enter the password. Okay. Otherwise, I'll not be able to access. So password here is learn@123, I think. Yeah, connected. See, I was able to log in. These are the login. These are the, if you click here, these are database. So there is my profile DB database and Postgres database. So there are two databases which are there here. Okay. Same thing. If you want to run the query, you can say, okay, SQL. Okay, you can run SQL script. You can right click on it and say create script, backup, all those things. Now, see, this is how, this is the command to create a database. To create a database itself. Create database, database name with owner, who is the owner, the username, encoding, all these things. Okay, this is how you create a database. Okay, if you want to create a table, you say create script. Okay, query tool. Query tool will open your query tool here. Okay, here you can run all your SQL commands. So you can see here Postgres/Postgres. So Postgres is the database. No, my profile DB is the database. This is the username. This is the password. Postgres/Postgres means username is Postgres and password is Postgres, and connected to my profile DB. So whatever you do here will go to my profile DB. Do you have a table here? Public, you see public here, something,
Publications.
publication. Okay, that means there is no table created here. Okay, there is no table here. Okay, schema public. Okay, table here. Details. Oh, you have details, testimonial. There are 3 tables created here. So I can say select star from user. This is how you get the data, read the data. We'll do all these things step by step. And this is the play button. Okay. So select from users. Users does not exist. Why users does not exist?
Capital U.
Let's see that. We'll put semicolon. No. Wait. I'll tell you there's a history behind it. No. This is my profile DB, right? And yeah, the user is something else. Okay, that's why it's not connecting. It is Postgres. Postgres does not have access to this. Okay, Postgres does not have access to this. Schemas, public. So if I say public here, okay, now if you run it, yeah, we'll see. Okay, maybe this Postgres does not have access to this. This is your this is the user here is something else. Here user is Postgres 1. Okay, Postgres 1 is the user here. We'll see. Okay, we'll create our own table and we'll see. Okay, or maybe what I'll do is let's copy this code from here and put it here instead of doing that. and new table. Okay, table created. Let's see where this table went. Public, refresh, public. No, right. Okay, see, it's not here. So that's why, yeah. Okay, so this is in this table, Postgres database, not my profile DB. Postgres does not have access to my profile DB. Okay, so now you say here, we'll go here to Postgres and say query tool. Okay, now you say select star from a new table, right? Okay, so see, because there's no data here, so they gave us the data structure, integer and character varying 10. Okay, when we insert into a new table, okay, I'll say 5 comma hello. This hello is case sensitive. Okay, now I will just select this and run it. Okay, it says values. Okay, sorry, I missed that values. Okay, so insert into table values. What is this? There are some minor changes, okay, with different databases. So once you start using, you will probably understand. Okay, so query returned successfully. It'll tell you how many milliseconds it took to execute it. Now when I go and select star, you see, column 5, hello. I can run it multiple times because I've not given primary key. So it will run 1, 2, 3, 4, 5. So now I go here and I select. Okay, so you see, it has added so many times. Okay, so yes, so install it and keep it. We will learn these commands and then we'll come back and we'll execute it. Is that fine?
Yes.
Any question, guys? No, right? Perfect. So we'll stop here. Please keep your database ready. And Monday we will learn our SQL commands. We'll start learning SQL commands.
Sir, can we not run in online Oracle?
You can do
Online.
whatever. That's what I said, right? Did I tell you not to? You can do it. Okay. Whatever database. Online version will not allow you to create any object. Okay. So that's why I don't suggest. You need to install something on your machine and see how it works. Okay.
Okay, sir. Okay.
The select command, I'll do it online. Select command because we need lot of data, we need lot of tables. So we will do online. But this creating part, create, insert, update, delete, we will do locally. Okay. So I would suggest you download any one database, whether it's Oracle also, it's fine. But don't use online because online will not allow you to perform this create, update, all those things. You can only perform select. Okay. So yes. You can download personal edition of Oracle as well. Okay. Sure then, guys. We'll see you on Monday.